Starting where we left off, we were about to solve some more equations. Here we go. It's very important that you make sure that you have a condensed logarithm. There is nothing multiplied outside the logarithm. You do not have two logarithms adding. You do not have two logarithms subtracting. You do not have a number added onto the logarithm. Make sure that that is your situation first, because the only way operations cancel each other out is if they are back to back, one right after the other. Then what I recommend you do is notice that the base of the logarithm is 2. The operation that will undo log base 2 is 2 to the power of. So you are going to 2 to the power of both sides of the equation. And in doing that, the 2 to the power of log base 2 are opposite operations that cancel each other out, which means the left side of the equation becomes just the 5x minus 1. On the right side, you have 2 to the power of 3, and you need to calculate that. So 2 multiplied by itself 3 times is 8. And then you have a nice equation to solve. So add 1 to both sides and divide by 5. But you do have to check for extraneous solutions. The only thing you have to do to check for extraneous solutions is go back to the original equation, identify what is going into that actual log function. 5 times a number minus 1 goes into the logarithm. If that number is 9/5, does that allow a positive number to be 5 times 9/5 minus 1? Is that a positive number? And it is, the answer to that is, it is the number positive 8. Positive. So it is not extraneous because it's creating a positive number to go in the logarithm. And if you take note, log base 2 of 8 is asking 2 to what power is 8, and that would be 3. And that's another way you can double check, did you do everything correctly? For number 4, you are going to again start off with the opposite operation of log base 3 is 3 to the power of. 3 to the power of both sides. The 3 to the power of log base 3 are back-to-back opposite operations that cancel themselves out. X squared plus 1, what was originally inside the logarithm, is now all that you have of the left side of the equation. On the right side, you have 3 squared, which is 9. And now you need to finish solving. If I subtract 1, I get x squared equals 8. And if you remember correctly from a while ago, if you don't have an x term and you just have an x squared, you can immediately square root both sides to undo the squaring. But plus or minus has to be there because that technically has 2 answers. And I want to start by identifying if there are extraneous solutions. So what you need to look at is, what is the expression going in the logarithm? If I put positive root 8 into the x, and I square that x, and then I add 1, that creates the number 9, and 9 is a positive number. That's good. And then you can also double check that log base 3 of 9 is asking 3 to what power gives me 9. and 3 squared is equal to 9. So that is checking that extraneous solution in full. The other number I have is negative the square root of 8. If it's negative the square root of 8, it is still having its entire number squared before adding 1. Negative root 8 squared is going to be positive 8. And again, I'm getting 9 going into my log base 3. 9 is a positive number, and log base 3 of 9 is 2, so it's all good. I have 2 answers to this logarithm, and I'm going to write that in simplified square root form. 8 is 4 times 2, and I'm allowed to separate multiplication over a root, and that becomes 2 root 2, plus or minus, and there you go. Number 5. I do not have a single logarithm on the left side. I need to condense this logarithm first. So I want to use the rule for when 2 logarithms are subtracting. I condense it by taking their insides and dividing them in the same order of the subtraction. So the 9x plus 14 is divided by the x minus 1. And now I condensed the left side. Now I have the situation of log base 5 of a bunch of stuff inside it equals a number. This is where you can bring in the inverse operation. Log base 5, the inverse of that is 5 to the power of. If I 5 to the power of both sides of the equation, I keep the equal sign that is between them. But here I have inverse operations that cancel each other out, leaving me with the 9x plus 14 divided by x minus 1. On the right side, I have 5 squared, because that 5 to the power didn't have a logarithm to cancel with. So it sticks around, and I have 5 squared, which is 25. So now it's more of a normal equation. Keep in mind that if you have a fraction when you are solving an equation, the first thing you want to do is multiply that denominator to the other side. So I'm going to multiply both sides by x minus 1. By doing that, I will have left only the numerator of 9x plus 14. And I'm going to distribute the multiplication of 25 over the subtraction to have 25x minus 25. Now I need to get x onto one side, so I'm going to subtract 9x. And while I'm doing that, I'm going to add the constant 25 over to the left side, so that then I have that this subtracts itself away, and then I have 39 on the other side. That subtracts it and adds itself away. 25x minus 9x will be 16x. And that gives me the number x equals 39 divided by 16. And let me double check on my answer for that I did not make an error. There we go, good. So then this is an explanation of basically what's going on with checking it. To check to make sure that it is not extraneous, I'm going to take this number, and I don't have to go through all the calculations. I'm going to erase stuff away so that I can show you that you're just checking quickly. If I take the positive number 39 over 16 and I plug it into this x, can you see that a positive number times 9 plus 14 is a positive number? You don't need to go fully through a check of, am I getting this right? You need to check, are you getting positive in going into the logarithm? Now, with x minus 1, the real question is, the answer you got, is it bigger than 1? Yes, it is bigger than 1. If it's bigger than 1, then you're getting a positive number going into that logarithm. And since all logarithms in the original equation, because this number allows only positive numbers to go into those logarithms, it is a correct solution, not extraneous. And extraneous happens because when we undo these logarithms, when we go through the cancellation and logarithms aren't there anymore, we take out the ability, we take out the issue of the domain. Because if you first look at this, you can only have x's greater than 1, and your x also has to be bigger than negative 14/9. But instead of worrying about that, you just check to make sure that your answer creates positive numbers going into those logarithms. Okay, number 6 is going back to the type 1 that we looked at in the previous video, because we have a logarithm on each side of the equation. There's no base written, so it's understood to be base 10. Now, I am not actually ready to just use the rule that we looked at earlier. Actually, let me go here to look at it. The rule we learned previously. There it is. No, that's not it. Sorry. Here we go. If you have a condensed logarithm, log base b of something, equals another condensed logarithm with the same base, then their insides must be equal, but they have to be condensed logarithms. So with the example we're on, if I can get to it, with the example we are on, I have a multiplication by 1/2 outside the logarithm. That means it is not condensed. So I can turn that into an exponent on the x plus 6. So the x plus 6 is going to have the power of 1/2 put on it. And that will then be what is going into the logarithm. So this becomes log of x plus 6 to the power of 1/2. And you might want to use the fact that a 1/2 exponent means square root. But if you don't do that right away, you can still get the correct answer. And I could have, right here at this point, just taken the insides and set them equal to each other. But I decided to rewrite the 1/2 exponent as a square root. Either way, you're going to end up with the same equation. So by simplifying as a square root first, I might see better where to go. But if I went ahead and just made the insides equal right there, then it might look like that. With looking at it from the square root point of view, for some of you, you might more easily see that that means square both sides to undo the square root. That gives me an x plus 6 equals 7 squared, which is 49. And then 49 minus 6 is 43, is my possible answer. If you have it this way, you might see that you need to square both sides, but it might be a little bit harder from that point of view to realize that that's what you need to do. So I recommend that you change a 1/2 exponent to a square root, and you're more likely to see that that's what you need to do. However, I am not totally done because I need to check. So I'm going to my original logarithm equation right here. And I want to make sure that if I substitute 43 for x, and there's x is only located right here. If I put a 43 there and I add 6, do I get a positive number? 43 plus 6 is a positive number. That means that as long as I didn't make any algebra mistakes, that is correct. But extraneous, it is not, because it is making a positive go into a logarithm. And that's it for solving log equations. Good luck, and I will see you later.